Assalamu alaikum warahmatullahi wabarakatuh. Um, Today we will talk about Introduction to a Plate Spatial Econometric by Attila Ferga. It is the prerequisites. First, basic statistics, statistical testing, and basic econometric, ordinary least squares, and maximum likelihood estimation and autocorrelation. Next, this is the outlines, introduction, the nature of spatial data, modeling SPICE, exploratory spatial data analysis, spatial econometric, specification diagnostic, new development in spatial econometric, and software option. Look, Insolence 1988 give a definition about spatial econometric. Spatial econometric is a collection of techniques that deals with the particularities caused by SPICE and the statistical analysis of regional science model, and increasing attention towards spatial econometrics in economics. There are two. This is maybe we can say that it is the reason why spatial econometrics is so fast, grows so fast, because this first, growing interest in agglomeration economics or spillover, and then diffusion of GIS technology and increased availability of geocode data. The nature of spatial data. There are two nature, or we can say that this is the characteristic of spatial data. First, data representation time series and versus spatial data. And the spatial effects, there are spatial heterogeneity and spatial dependence. Next, spatial heterogeneity, structural instability in the form of non-constant error variances. So spatial heterogeneity we can call with spatial heteroscedasticity, and then non-constant coefficient. So we can set we can call spatial heterogeneity with spatial spatial regime, with spatial regimes. Now, spatial dependence, or spatial autocorrelation, or spatial association. In spatial dataset, it is the characteristic of spatial dependence. In spatial datasets, dependence is present in all directions and becomes weaker as data locations become more and more dispersed. Crazy in 1993. And then Tobler's the first law of geography: everything is related to everything else, but near things are more related than distant things. And spatial dependence, or spatial autocorrelation, has two kinds, because if we talk about correlation, there are positive correlation and negative correlation. So in spatial data analysis, Or in spatial econometric, we have spatial positive autocorrelation and negative spatial autocorrelation. Positive spatial autocorrelation, and this means that high or low values of a variable cluster in space. And negative spatial autocorrelation, correlations are surrounded by neighbors with very dissimilar values of the same variable. Spatial dependence, spatial autocorrelation, spatial association. Spatial dependent, another name of spatial dependent is spatial autocorrelation or spatial association. Spatial dependent in dependence in time and dependent in space. So I repeat again that if we set spatial dependence in time and dependence in space. In time, one directional between two observations, and in space, two directional among several observations. Spatial dependence, spatial autocorrelation or spatial association. Two main reasons. First, measurement error and spatial interaction between spatial units. Modeling in space. Spatial heterogeneity. There are two kinds of modeling in space. First, spatial heterogeneity and spatial dependence. Spatial heterogeneity is conventional non-spatial models. Random coefficient error component model are suitable. And spatial dependence need for non-conventional approach. Spatial dependent modeling requires an appropriate representation of spatial arrangement. Solution relative spatial position are represented by spatial weight matrices. Modeling space. First, binary contiguity weight matrices. Spatial units as neighbors in different orders. First, second, etc. Neighbors have a command border or being situated with a given distance band. And second, inverse distance weight matrices. Modeling space, binary contiguity matrices, rock or queen, like this. And Wij equal 1 if I and G are neighbors, 0 otherwise. A neighborhood classes first, second, etc. Inverse distance with weight matrices, like this. And modeling space rule standardization like this. Wij equal Wij per sigma Wij. Row standardized spatial weight matrices for easier interpretation of result and for ML estimation computation. And spatial leg operator Yi Wy is a spatially lagged value for the variable y. In case of arrow standardized w, yi is the average value of the variable in the neighborhood in the whole sample with the weight increasing with increasing distance. Exploratory spatial data analysis, measuring global spatial association, de Morin's eye statistics. Like this, this is for W not row standardized, and this is for row standardized. Global spatial association, basic principle behind all global measures, the gamma index, neighborhood pattern and value similarity pattern compares, global spatial association, significance of global clustering, test statistic compared with value under each null of the non-spatial autocorrelation, normality assumption and permutation approach. This is plot of Morin's eye. This is so the strength of association between spatial leg and the variable dependent line. Local indicators of spatial association leg, or LISA. The Morin's scatter plot idea. Morin's eye is regression coefficient of the regression of YWZ on Z when W is a row standardized like this. Regression line general pattern points on the scatter plot, local tendencies, outliers, extreme to the central tendency, leverage point, large influence on central tendency. This is a scatter plot of Morin's eye. Local indicators of spatial association. The local Morin's statistic is significant test randomization approach. Spatial econometric. Spatial lag, there are two models, spatial lag model and spatial error model. The spatial lag model, lagged value in time, yi minus yt minus k, lag value in spice problem, multi-oriented to directional dependence, series lost degrees of freedom. Solution is spatial lag operator wi. The general expression for the spatial lag model is like this, where y is n by one factor of dependent observation, wy is an n by one factor of lagged dependent observation, rho is spatial autoregressive parameter, x is an by k matrix of exogenous exploratory variable, and beta is k by one factor respective coefficient. Spatial lag model estimation problem, endogeneity of wy correlate with the error term. OLS is biased and consistent, maximum likelihood and instrumental variable estimation. This is estimation in spatial lag model. ML estimation, the log likelihood function, this maximizing the log likelihood with respect beta, rho and sigma, give the value of parameter that provide the highest likelihood of the joint occurrences of the sample of dependent variable. Estimation to SLS, suggested instruments, spatially lagged exogenous variable. Now spatial error model y equal x beta plus epsilon, with epsilon is lambda w epsilon plus c, where lambda is coefficient of spatial lag autoregressive error, w epsilon error in c are independently distributed. OLS and bias estimation with method OLS and it give result unbiased but inefficient. So the alternative we use ML estimation. The likelihood function for the regression with spatially autocorrelated error term is like this. This is the function of likelihood function. Specification task, Moran's formulation, and distribution normal 0,1, source, Clift and OR. Test LM error formulation like this, and distribution k-square, LM error lag, LM lag, and LM lag error. Steps in estimation with OLS. Estimate OLS. Study the LM error and LM lag statistic with ideally more than one spatial weight matrices. The most significant statistic guides you to the right model. Run the right model. Spatial econometrics new development, estimation GMM, and spatial panel model, spatial probit, logit, and tobit. Study materials, introduction, this, advanced answering spatial econometric, and this is the software option, Geoda, SpiceTab, R, and MATLAB Pro Tools. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.